Okay, Trig, I don't think I finished 6-1 on the last video, so this is the end of 6-1, and then I'll start 6-2. In your notes, you're supposed to take the sine of the inverse tangent of 3/2. Now remember, the inverse tangent of 3/2 means tangent of what angle equals 3/2. Okay, sorry for my writing here, having some arm issues. So the tangent of theta equals 3/2. Here's a drawing of that. Okay, I'm going to draw an angle theta that has opposite over adjacent being 3/2. So basically what I want is the sine of theta. Well, what do you think? A little Pythagorean theorem, right? 2 squared plus 3 squared equals whatever squared. Oh, I'm off here. Okay. So when I do 2 squared plus 3 squared, that's 4 plus 9. Okay, so that's 13. So this side must be the square root of 13. So the sine of that angle would be opposite over hypotenuse, 3 over the square root of 13. And then we can also do that on the calculator and get a decimal approximation to make sure that we're right. Same thing here. Cosine inverse of -5/13 means cosine of what angle equals -5/13. So I drew a little angle. Okay, here's my XY axis. So I'm going -5 and up, up, oh, I don't know how much, up something. And then here's 13. Okay, I drew an angle such that the cosine of this angle, adjacent over hypotenuse, is -5/13. Pythagorean theorem. -5 squared plus whatever this is squared has to equal 13 squared. I got y to be 12. So then I know that the tangent of that angle is 12 over -5, opposite over adjacent. 12 over -5. And when I do it in the calculator, I get -2.4, which was exact. I think you've done that maybe before in pre-calc, but just a little refresher. Same thing here. Evaluate each expression without using a calculator. Arctan of the square root of 3. That means the tangent of what angle is the square root of 3. Maybe you remember what it is. If not, we'll draw an angle theta, or an angle A, in this case, that has a tangent of square root of 3. And when I do my Pythagorean theorem, I get this side to be 2. Okay. Over here, I'm going to draw a sine that has, or an angle that has a sine of 1/3. Oh, I did that here, sorry. A sine that has opposite over hypotenuse is 1/3. Pythagorean theorem gives me 2√2 there. So now I know that I want the cosine of this angle plus this angle, so I'm going to use my cosine of a sum. Cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle, and then multiply those all together. You can just use your triangles. Okay, we're kind of going back to triangle trig. Tangent of twice this angle. So I drew an angle B such that the sine of it was 2/5. Used Pythagorean theorem. 2 squared plus what squared equals 5 squared. Square root of 21. So the tangent of twice an angle, I use my formula sheet to know what that is. And I put in the tangent of B. Tangent is opposite over adjacent. So 2 over square root of 21, that whole way. Okay, here, this is in your book. I think I put it in your notes with blanks, so you might want to fill that in. Okay, here are your inverse trig functions, their domains, their ranges. Along with the range, they kind of mention which quadrants that would be in. You know, if you think about the interval from -pi over 2 to pi over 2, here's -pi over 2, there's pi over 2. So those quadrants are 1 and 4. That's all they're saying. If I'm going from 0 to pi for inverse cosine, those quadrants are 1 and 2. It's kind of helpful sometimes to keep that in your, just to keep that in the back of your mind when you're working with some of these. Okay, We're going to go a little bit, instead of having tangent inverse of a certain angle, we just call it u. All right, inverse tangent, tangent inverse of u. We want the sine of the inverse tangent of u. Well, I can't use my calculator anymore. But I do know that the inverse, that I know that the tangent of some angle is u. So here's my angle theta, such that the tangent is u. Okay, I let this opposite be u, adjacent be 1. Okay, and then I did the Pythagorean theorem. 1 squared plus u squared equals the hypotenuse squared. So my hypotenuse has to be square root of u squared plus 1. Okay, and if u happens to be negative, doesn't really matter. I still get square root of u squared plus 1 because the distance will be the same. Okay, so the sine of the inverse tangent, so the sine of those angles, the sine will be what? Opposite over hypotenuse. So u over the square root of u squared plus 1. I would be fine with that, guys. If you don't take the time to rationalize it, that's fine with me. Okay. If u is a positive angle, we do get a positive answer. If u is negative, we'll get a negative answer because, you know, u will be positive, so I'll have a positive over positive. The denominator is always positive, but this part is positive or negative. Sorry, I'm doing a video. Oh, let me stop. Okie doke. Let's try this one. Same type thing. Write the trig expression as an algebraic expression of u. We have to realize we're taking cosine of twice an angle. And I'm going to use this formula. I know there's 3 of them to choose from, but this is one I chose for this one, since it involves sine. I drew an angle such that the sine of it was u. Here's the angle, okay? The sine of theta is u. So now I want cosine of 2 sine theta, which is this. And so that's 1 minus 2u squared. Once you get it in your head that the inverse trig, inverse sine is asking for an angle, it really helps. Try this homework. Page 264. 13 to 67, do every other odd, guys. I know that seems like a lot. And I also want to throw in 27. Do 13, skip 15. Do 17, skip 19. You got the idea. Same with 75 to 103, every other odd. And then also do number 109. It's 24 problems. It's worth it. Okay? Please. I will go over those when I see you next. This part I love, solving equations. It's just like solving equations in algebra, except for we're using trig, but we still do the same idea, okay? If I want 2 sine theta plus 1 equals 0, I still do the same things I would do if it was 2x plus 1 equals 0. And what would you do? Subtract 1, divide by 2, right? So 2 sine theta equals negative 1. Sine theta equals negative 1/2. The difference is, here when I get x equals negative 1/2, I'm done. Here I'm not done. I have to take the inverse sine of each side, right? I have to undo sine theta. So I'm thinking, let's see, sine of what is negative 1/2? That means the y coordinate is negative 1/2. Where is that? Here. Where is that? Here. Okay. We want the answer from 0 to 360. Oh, we're in degrees right now. Okay. So from 0 to 360, we would call that, how many degrees that is? And what's this one? Oh, sorry. 330. Okay. Let's try it on the calculator. On the calculator, in other words, when I got here, theta equals, thinking, oh, I want to take the inverse sine of negative 1/2. So what will happen oftentimes is people will use the calculator. I'm going to change my mode. of course, to degrees. I'm in radians. Okay, since it's asking for degrees, might as well do that. Inverse sine of what, -1/2? Oh my gracious sakes, sorry. Is -30 degrees. Not completely wrong answer. It gave me an answer that's coterminal to the answers that I want. The calculator, in this case, will help you find the answer. Don't just write down what the calculator gives you. I don't want a negative angle. It clearly says over the interval 0 to 360. And the calculator told me that the answer was -30. That's correct, because remember, inverse sine is limited to the first and fourth, to these two quadrants, -π/2 to π/2. It's not going to give me this answer. I have to find it. And I have to call -30 330. Okay? Do you understand that? Please, please, please. The calculator is helpful, but it's not going to give you the right answer. Most of the time, all it does is give you a clue. It's a big help. I shouldn't say it gives you a nice clue, but it doesn't give you the whole picture. Now, that's if the question asks from 0 to 360. If it says for all solutions, because there's tons of these, as we know, I could go around a couple times. I could go around this many times. I could go negative. Okay, so then we have to write 210 plus 2 pi n and 330 plus 2 pi n. I wouldn't say plus 2 pi n. I'm silly. Look at me putting radians and degrees together. Good grief, Kelly. I'm so messed up. 210 plus 360 n and 330 plus 360 n. Okay, just to show, and usually we write where n is any integer. Okay. Also, sometimes I just look at the graph. They're asking me, where does 2 sine theta plus 1 equal 0? Here's y equals 2 sine theta plus 1. It kind of reminds me, it's going to hit 0 twice. As a quick reminder that, okay, the calculator is going to give me one answer, but I actually have to find 2. Okay? And then be careful. Are they asking for 0 to 360? Are they asking for 0 to 2 pi? Are they asking for all solutions? Okay, that's where it gets tricky. All right? So, let's try this one. I don't have it equal to 0. So just like in a quadratic or any place where I might want to factor, I set things equal to 0. We're going to do those same type things in solving trig equations. Okay? I'm going to bring my sine theta out. Tan theta minus 1 equals 0. Factoring. The reason I do that is now I can say, well, this can happen 2 times, either when sine theta is 0 or when tan theta minus 1 is 0. In other words, when tan theta equals 1. They want the answer from 0 to 360. So I know that sine equals 0. Let's see, at 0 or pi. I'm sorry, I keep going to radians and they're asking me for degrees. 0 or 180. That's where the y-coordinate is 0. Where is tangent positive 1? Isn't it 45 degrees? Or where else? Where else is tangent positive? In which quadrant? Third, right? So what's that? 135, or 225 degrees? Okay, so we have 4 answers. 0, 180, 45, 225. Any of those answers, the sine theta times the tangent of theta will equal the sine of theta. Okay? See what they're cautioning us about here. Yes. Please, you don't do this in algebra. We don't do it in trig either. Don't just divide both sides by sine. You're going to miss both these answers in. Okay? You're going to just get tan theta equals 1, which gives those 2 answers. Okay? You don't divide by a variable expression. You set equal to 0 and you factor, just like we do in algebra. Okay? All right. Good luck.